start with, and then if anybody's got questions, we can go through them. So this is a workshop for your laboratory. So first of all, as I said, in each of the labs, and when we've done we talked about the coursework, the people lose marks on this coursework on the discussion, okay? And you know, there's a potential to fail this coursework just based on the discussion. As 40% of the marks are the discussion. That is not just about a summary conclusion of the graphs in your lab, okay? It shouldn't be that at all. It's got to be a lot more than that. It is about surge pressures, water hammer, and how you can stop them, how you can control them, how you can minimize them, the different techniques, the different equipment, appliances that are available. And it's a generic putting the context of the little surge tower into the lab into an engineering perspective. Okay, so it is not just a summary of what you found in the lab. And if that's all you're doing, then you run a high risk of failing this lab. Okay, so every year people give me 5 lines on a conclusion for 40%. If you get 10% for that, you're lucky. So you really need to focus on that. So some of the things I've noticed with the cup, I haven't had many in, to be honest. I've only had a few in. But first of all, standard report formatting. So you need a front cover, you need a contents page, you need to have all your figures labeled clearly and everything referenced, Harvard referencing. Your final years, you shouldn't be failing at any of these things now. Your report should be almost perfect, really. You're doing your dissertation, you need to be following the same sort of guidance as that. So I've noticed that abstracts are not containing conclusions. So an abstract should include a high-level summary of what your findings are. If you pick up a journal in the library, the abstract should be enough to tell you whether or not you want to read the rest of that journal. That's the idea of the abstract. It gives you some idea of what was involved in the report or the article and what were the findings. So just an introduction as an abstract is not an abstract. Okay, so that's important. So include high-level findings in your abstract. I haven't seen anybody's yet that's done that. As I said about the discussion, that's absolutely key. Don't forget to reference everything. Even if you're using theory that I've given you, you know, that needs to be referenced as well. That's the Armfield referencing. The information that you've got in your course notes is from the Armfield, sorry, the tech equipment itself, not Armfield, that's the Flume, the tech equipment itself. Okay, so make sure that you've included the reference points for that as well. Your images should be referenced. If you didn't take them, they are not yours. You need to reference your images and where you found them. So that's the other thing I've noticed is missing. Methodology, your methodology, I know I said I don't need War and Peace on methodology. I don't want you doing a lift from the coursework because you didn't do everything in that coursework. All you need to do is write out a very clear set of steps. A bulleted list is absolutely fine. It doesn't need to be paragraphs and paragraphs. A bulleted list so that if somebody else picked up your report, they could follow the process and repeat the lab. Okay, that's all it needs to be, so somebody else can follow it. So you read it through and think about whether or not that process is sufficient. Make sure you've referenced it to images. You know, I know a lot of you took photographs of the equipment in the lab. We are restricted with time, so you're very welcome to use the images I put into the presentation. That's absolutely fine. The water hammer experiment, I did say to you, don't need to plot that graph for the second one where you've got the pulse. So when you can see that water hammer and you've got the pulse that looks a bit like that, you don't need to plot that. So don't go searching for data to try and plot that for the water hammer experiment. But again, you just want to reference an image to show what did that look like. So, you know, I know a lot of you took a photograph of the screen, which is fine for that one. Okay. So methodology, make sure again you're doing theory. You should include theory in your report so you can see the breakdown of the marks. So in your coursework descriptor, you can see on here, so presentation of report and introduction, that's 10 marks. That includes your abstract being an abstract and not an introduction. Theory, apparatus and methodology, 20 marks. Okay, that's not a difficult 20 marks to get. You can see the images, you've taken photographs, you can write out the process, but you need to include theory. So that is the theory behind surge pressures, water hammer, and that should be, you know, in your own words, but referenced. So make sure that you reference that. So the final 2 points, the data presentation, analysis and interpretation, so that's the graphs. So on the summary pages, It tells you exactly what you need to be doing. Now, a lot of people have said, how many graphs do I need to do? Well, as a minimum, you need to do the number of graphs that the report asks you to do. And then it's up to you to decide how else do you want to present your findings. So, you know, you've got experimental and theoretical. If you want to present them in tables, if you want to present variances graphically, that's up to you to how you present your data to show the differences. You know, as long as I can see it and you've explained it, that's what's important. But the minimum number of graphs is what you're asked for. Again, your final year, you should be doing more than this specifies. Okay, so, you know, you have to compare experimental to theoretical. You decide, how do I present that data and analyze it correctly? So going through the requirements of the lab. So first of all, you've got in the coursework, you've got all the calculations. So they're all in here. Remember I said, as I'm sure you've noticed now, that the VDAS software itself does all of those theoretical calculations for you. So you've already got to check that your values are correct. So you've got all the calculations in here. You can go through that and make sure that you are coming out with the same numbers, basically, because it's all in the notes, everything you have to calculate. In terms of presenting your findings, so your results analysis, so the one thing I've noticed people are doing incorrectly, the first part of this results analysis asks for you to, for the steady state surge level, plot a graph of oscillations against time. Okay, so we did 5 runs. We controlled the discharge level by controlling the height in the surge tower, but we did 5 different readings where we were trying to drop by about 50 mil each time. Okay, the oscillations, when you plot them, I don't want to see this. Okay, that's of no value whatsoever. Your oscillations should be, I don't know if you remember, there was a slight, you get a slight vibration at the start. So again, in each of those labs, I did talk about issues with the equipment. So, you know, errors, things that come up will relate to the equipment itself. We were all doing those labs. Everybody had to go at doing those labs. Everybody's doing it differently. Everything was read by eye. So think about that. But when you plot those oscillations, they need to be overlaying. So you need to plot each of those 5 from the starting point of where the valve was closed. The data beforehand is not relevant. You know that was the steady state surge level, so we don't need that. We need to plot those until that diminishes, but they need to be overlaid on top of each other. You are comparing the time period and the maximum surge height. In those files, you have the oscillation values. The VDAS records a value of that surge height every 0.04 seconds. So you'll have time on your x-axis and then the height of the oscillation on your y-axis. Okay, but they need to be overlaid like that. So that seems to be the biggest problem I've seen so far, is that I've had a very random selection of graphs. Only a couple actually look like that. Okay. You have all of that data. I know it's a lot of data, but it's Excel. So it'll take you seconds to pull out that data and turn it into a graph and then identify where the starting point is. Okay. You can plot the raw data to start with if you want to, put that into appendix and then show where you have then identified the results. Your graphs should be in the main body of your report, not in your appendix. Okay, those are your results. That's what you're discussing. Reams and reams of data go into an appendix. Graphs that illustrate results need to go into the main body of your report. So make sure they are in there. Okay, so that's the first graph that you have to plot. So there's not an option on that one. Don't plot them separately. You are comparing them. It's important that they're all on the same graph, and then you discuss the variations between the time periods. So remember, we recorded the time period between the first peak, and also we recorded the maximum surge height. So you need to discuss those. Okay, any questions on that bit? Oh, sorry, Pedro. Okay, so the Harvard referencing guide is on the library website. That will show you exactly how to reference absolutely everything. You should all be using that guide for your dissertations anyway. Okay, so that guide you were given in your first year, everything is in the Harvard referencing guide, referencing blogs, referencing discussions, interviews, everything is in there. And that's what you should be using for all of your reports. Okay, if anybody can't find it for any reason, email me and I'll send you a copy, but it's on the library website. So just make sure you access that for everything. Okay, that's absolutely critical for your dissertations as well, because your sources of information should be, you know, a variety of places. I know with something like this, you might be less inclined to be looking at questionnaires and interviews, but you should still be looking at journal articles, you should still be looking at books, conference proceedings, all of those things should form part of this report, okay? Not just Wikipedia, all right? It's a good starting point, it's not peer reviewed, right? So make sure that you've got good sources and a variety of sources. So everybody okay with the oscillations, plotting those graphs for oscillations? Yeah? Okay, so that is really important that you do that bit. Part 2, create a chart of head loss versus volume flow. So you've got the volume flow rate. The other thing to make sure when you're doing this, remember, is that your units are the same. So there were a variety of units. Your volume convert to meters cubed per second, and then make sure that any of your surge tower values are all in meters as well. Don't mix your units, okay? So I don't want to see millimeters and meters on the same graph, or liters per second. You know, just make sure that you can compare exactly. So make sure your units are consistent. So part 2 on here, create a chart of head loss against volume flow rate. Volume flow rate is in your files. The head loss is in your files. That's all there. Remember then that you are comparing that to the theoretical curve. So if you remember in class, you can go back over this, we had the curve for the equipment. So there was the curve that plotted for the equipment itself, for our surge tower, and you are plotting that data and comparing the equation, okay, to see whether or not the exponential is the same. And it's an exponential value. So that graph is in your notes from, I think it was just before Christmas that we did that. So make sure you're comparing that graph, okay, and looking at the value for your curve as well. So that's your second graph. You've got the calculations, obviously, to do calculation of the theoretical time period. You've got the measured time period in there as well. So you're comparing it to the theoretical, but also between the different flow rates as well. Okay, so you're not just comparing, you know, each of those lines to itself, but also the fact that there were 5 different values for flow rate. How does the time and the surge and everything compare when the flow rate is different as well? And what are the reasons for that? Part 4 then is a chart of experimental and theoretical surge amplitude against volume. Okay, so again, put both of those on the same graph because you want to be able to compare them. So those are the minimum amount of graphs that you've got to have in there. And then anything else you think you want to represent variations in your data, you know, some of the, remember as well to scale. So, you know, I've noticed some people will put a graph in that, you know, if you're looking at that last part, which is time period against measured time period, or experimental and theoretical surge amplitude, you might have a graph like this. One of your points might actually be out slightly. So what I've noticed people do is they'll put a graph in and then it looks like that. Well, that all depends on scale. That does look like a huge error if your scale on your y-axis is enormous. So put it into perspective as to how large is that error actually? How much does it compare to the actual value? Don't say it's a huge difference and your scale is enormous, okay? So don't just plot graphs and then expect the graphs to tell you what's going on. Make sure you can interpret them, make sure your scales are right, your values are right, your units are right. Okay, there's a lot more to interpretation than just drawing a graph. And then obviously discuss the impact surge pressures have on a system and how they can be controlled. So that's part of your discussion. So your discussion is about your lab, your findings, and then how that relates to engineering, not just the lab. It's a very small surge tower that we've got in the lab with a whole range of different issues. The fact that we're all different people looking at it and controlling it as well. But then the engineering significance, the bigger picture of surge pressures and water hammer. Okay, 40% of the marks. Please don't forget that. And then the water hammer, remember that you have we did 3 readings for the water hammer. So we only did that to get a statistical average. We did maximum flow rate. So we weren't doing different flow rates for that one. So again, you know, you're not having to plot different flow rates for that last one. You could just take an average of those 3 data runs and that's the data you're going to use. Okay. If there is a significant difference between 2 of your lines, explain it. And then if you feel, so for example, you know, we take 3 as a statistical average because if we have 2 that are very different, the third one will give us an idea of which one should be more accurate. So if one of your data lines is completely out for any reason, then explain and only use 2 that are similar. Okay, Okay, so look at the data. Don't take an average if two of them are 15 bars and the other one is 100 bars, for example. It's not, because obviously the machine doesn't do that. But, you know, just think about the data before you just take an average and use it. Make sure that the summary of raw data is in the appendix. As I said, the Excel will, because it will record every 0.04 seconds, it's going to be a long file. All of that doesn't need to be in there. The summary headlines, the theoretical, the experimental values, those can go into your appendix as Excel outputs. And then obviously you are showing how you found those values and how you're discussing them. But the reams and reams of data, that doesn't need to go in there. Please don't put Excel documents in the middle of a file. And also, I'm sure you all know this by now, if you embed an Excel file into a Word document, I can't open it and turn it in. Okay, so you know that you can only submit one document. An embedded document won't open. So make sure that you do it as an image, a snapshot, or you import it as an Excel image directly into your Word file if you want to do it that way. Okay, an embedded file will not open. So remember that for your dissertations as well. So the water hammer one, obviously the experiment itself was a lot shorter, but there's still a lot to be discussed. You're looking at the speed of that surge pressure wave. When we close the valve suddenly. You've got the distance between the two transducers, so you can calculate how long it takes for that pressure wave to travel between the two. Okay, you've got the image, of which there is one on file that you can use to show what those two pulses look like. The values that I gave you in your Excel files are the values to use. So I don't know if you remember the wave sort of did this, and then the second one did that. Okay, so I've taken that into account. You don't need to worry about that distance. Those are the values to use. Okay, so it's an average of those three. Again, make sure that if any of them look like they're completely out, you just use two and you explain why you're using two, but include the three in your appendices to show the raw data. Again, the results analysis for the water hammer, compare theoretical and measured, and then discuss the implications. Now, when you write this up, obviously these are two different experiments, so your methodology will be different, but the setup and the equipment can all be referenced back to one set of images. You don't need to repeat your images for two experiments because obviously the setup is the same. You can then just highlight the different pipes and valves that are being used for the water hammer in comparison to the surge pressure. Okay. Let me see if there's anything else I wanted to. No, so that's the notes I made on some of the files I was getting submitted. So again, you know, professional report formatting, contents page, make sure you've got all of that information in there. Referencing should be Harvard referencing. Make sure that that is correct. Don't leave anything out. Use Turnitin to check that you haven't missed any referencing, you know, because again, you know how serious plagiarism is in the university. If you get a, you're not going to get a 0 because first of all, it's going to record the front cover as a match anyway. You know that, you've all used Turnitin. But if you have a percentage, make sure that you have referenced anything it highlights. So go back and look before you do your final submission to make sure that you're not missing any references. Okay. And this should be independent work. Everybody within a group had a separate file. So, you know, you will have some similarities because obviously the theoretical calculations are going to be the same because the equipment is just using the dimensions of the equipment. So you will have similarities in there, but it's important that this is your own work. Okay, so use Turnitin appropriately to check on your work before you submit. Okay. Okay, so any questions about any of that? No, anyone online? Okay, so this is a workshop now, so you're welcome to carry on working on your labs. Work on your labs here if you want to. Obviously, I'm going to stay here now, and if anybody's working on it has got specific problems they want to ask, then that aren't just sort of show me how to do the calculation, because you need to do the calculations yourself, then I'll come around and help people, obviously wearing a mask as well. Okay? Okay. If you are happy and you want to just work on your lab now, you can work on your lab, but I'm going to stay here for people that need help. Okay? Oh, and I will just do a hard copy register as well.